There are two fundamental laws governing electrostatic fields. The first and foremost law is Coulombs law, and another law is Gauss law. Here, let's see what Coulombs law is. This law is formulated by French Colonel Charles Coulomb in the year of 1785. This law deals with the force a point charge exerted on another point charge. We know what a charge is, but what exactly is point charge? A point charge is a charge located on a body whose dimensions are much smaller than other relevant dimensions. So this point charge can be considered or can be regarded as a collection of electric charges on a pinhead. So a point charge is not mere an electron or a proton for that matter. It's a group of electric charges or can be considered as a collection of electric charges on a small point. Hence the name point charge. Coulomb's law states that the force F between two point charges Q1 and Q2 is, first one, along the line joining them, and this force is directly proportional to the product of the charges, and it's inversely proportional to the square of the distance between them as well. So let's draw these point charges Q1 and Q2 in space, and let's define Coulomb's law mathematically. So here are the 2 point charges Q1 and Q2 located at a point vector R1 and R2 respectively from origin. So that R12 vector is a vector from Q1 to Q2, hence it is R12. So first statement of Coulomb's law is the force is line joining these two charges. It's along the line joining two charges, and F12 is accordingly so. So this force, as we have seen, that it is proportional to the product of the charges Q1 and Q2 and inversely proportional to the square of the distance between them. So this proportionality constant can be considered as K, as given by the formula F is equal to K Q1 into Q2 divided by R square. So what exactly is the proportionality constant? In SI units, this K is defined to be 1 by 4 pi epsilon naught. That new term epsilon naught is called as permittivity of free space, and the value of epsilon naught is given by 8.854 into 10 power minus 12, or also mathematically it can be written as 10 power minus 9 divided by 36 pi. It's 10 power minus 9 by 36 pi is used to ease mathematical calculations, and the unit of this permittivity of free space is given by Farad per meter. So substituting this proportionality constant into the above equation, we get F is equal to Q1 and Q2 divided by 4 pi epsilon naught R square. Using the vector notations, this F can be now written as it's F12. It's a force on Q2 due to Q1 is equal to Q1 and Q2 divided by 4 pi epsilon naught R square into unit vector R12. That unit vector R12 defines the direction of the force. Since force is a vector quantity, the scalar of it is given by Q1 into Q2 divided by 4 pi epsilon into R square, and the direction is given by the unit vector, which is line, it's along the line joining the 2 point charges. So we know that from vector theory, R12 vector is equal to R2 minus R1, where R2 and R1 are the position vectors of Q2 and Q1 charges respectively, and R is a scalar quantity which is nothing but modulus of R12, its magnitude of that vector R12, and hence unit vector AR12 is given by R12 vector divided by the magnitude of it. And substituting all these values into F12, we arrive at F12 is equal to Q1 into Q2 multiplied by r2 minus r1 vector divided by 4 pi epsilon naught into magnitude of r2 minus r1 to the cube of it. And it is noteworthy that F21, the force on Q1 due to Q2, is in the opposite direction of F12, and hence you can write F21 is equal to minus of F12.